is important. So between these, so the first question is actually regarding the Verilog and VHDL. So Verilog is why is Verilog is important? This was the first question actually. So the reason for this one is C type of language. So it is very easier to learn this Verilog. And VHDL is old version. Basically, VHDL is like Pascal and all. Okay. Now the people are familiar with C, and so Verilog people can easily understand the Verilog. And this is new version and compared with the VHDL. This is one advantage. Another advantage is actually Verilog will be normally used for the most of the industrial applications. And the second part of the first question is regarding the embedded systems and VLSI technology. For machine learning and all, actually, if we take the difference between the VLSI technology and machine learning, sorry, VLSI technology and embedded systems. So embedded system is actually basically a system, whereas VLSI technology, using VLSI technology, you can go up to the fabrication of the microchips. So we can say that even embedded systems design also they will use VLSI technology, but the VLSI technology is a bit advanced one. Once the system is designed, so you can verify the system functionality using many ways. So one of the good approach is if you fabricate the system on the IC, then you can claim whatever the advantages of that particular system. Okay. So in VLSI technology, we will go up to the IC. In system, we will be having block diagram approach, and that system functionality can be verified by using either FPGA or any other techniques. And regarding this machine learning, so one of the recent research area is machine learning on chip. Okay. If you want to fabricate the chip correspond to machine learning algorithm, say perceptron, so DNN, say for example a decision tree. So we can directly fabricate the IC correspond to this one. This is a challenging task. This is one of the recent research areas. So in embedded system, what we'll do is just we will discuss the system in block diagram approach. Whereas if we want to go up to the VLSI technology, we can fabricate the whatever the machine learning algorithms onto the IC. That is the difference between these embedded systems and VLSI technology. For machine learning applications, or it's applicable for any other applications also. So in fact, one of my research area is also same. So I'm working on machine learning algorithms and corresponding architectures also. Regarding the second question, actually, most of the books actually this carry propagate. This will be exclusive or operation only. But there is one book, that book also is good book only flight. So I'll just check because this is assignment 2 long back. I'll just check with my teaching assistants because they will deal with all these things. So I'll just check with the teaching assistants. So I'll see that so you'll be get benefited. So I'll just see that if your options is either D or A, you'll get the marks. I'll see if it is possible. If you have any other questions, you can ask. Because time is limited, how to ask quickly. To explain filters means actually a filter is basically a frequency selective network. Like if I take a example, in the communication, normally we'll transmit the signal. So at the receiver, what happens is, in addition to the desired signal, there will be some noise due to many reasons. Atmospheric noise, impulse noise. There are a lot of noises are there. So the received signal will be a sum of the desired signal plus undesired signal called as noise. Okay. So normally the noise frequency range will be wide. Almost it will be having, if I take additive wide Gaussian noise, it will be having all the frequencies 0 to infinity. Okay. Whereas the signal that we are interested, desired signal, will be having some specific frequency that will be decided at the transmitter. So at the receiver, if you want to remove the noise, okay, if the desired signal is up to say some 50 kilohertz, and above that is only noise, then you can design a low pass filter with a cutoff frequency of 50 kilohertz so that all the frequencies above 50 kilohertz will be rejected. But in fact, 0 to 50 kilohertz also there will be some noises. For that, we have the other techniques to remove those noises and all. So basically, filter is a frequency selective network, so which selects a band of frequencies and rejects the other frequencies. There are a lot of applications of the filters. In biomedical, we have, if you want to record the ECG or EEG, there will be a 50 hertz signal that comes from the power lines. Yeah, that is undesired one. So in order to remove that, you can use a notch filter. A lot of plenty of applications are there. Basically, to select a group of frequencies, a set of frequencies, and to reject the other frequencies, we will use the filters. So these assignments and all actually, I don't remember because what is that question number 1 in assignment 7 that I have to look. You can mail to me or you can put in the discussion forum. I will discuss with the teaching assistants. Actually, these things will be dealt by my teaching assistants. I don't remember what is question number on A7. So you can discuss, you can send the mail. So next question is like Verilog differentiate between task and function. I don't exactly understand what is this question. What is that you want actually? Can elaborate between again elaborate your question on Verilog differentiate between the task and function. Task is actually goal. Like if you want to perform the end operation is a task. Function means actually here you have to define the function. There will be no built-in functions. Again, another question is on about system Verilog. So what is the question? I don't understand actually. What is system about system Verilog? What do you want exactly? So confused about the function. Can you give an example of one function that you are not understand? It will be A. If selection is true, then the first value. If select is wrong, then the false, then the second value. If select is 1, then the output will be A. Instant date means it's something like subroutine actually. For example, if I take the full adder, I can implement the full adder using 2 half adders. So instead of writing the 2 full half adder programs codes, you write one time and you just call with different variables. Say in the first full adder, the input should be some AB, output will be say C. In the second, the inputs will be say DE and F is the output. Then those values that you have to mention so that it will perform the same function. Once if you write this half adder and if you instantiate that twice, then the half adder function will be performed in the main program. Signal strength is actually basically if I propagate a signal. See? So there will be some, if it propagates through the resistance, there will be some resistances if the input signal is say 5 volts. Okay, if I have, this is the length of the wire. Here I have feed 5 volts. At the output of the wire, it may not be 5 volts because there will be some drop in the voltages. Okay, so how much voltage drop is allowed still without changing the strength of the signal? Say logic 1 I have paid. If output is also logic 1 with some drop in the voltage, then it is allowed. If I feed logic 1, if I get logic 0, then it will be wrong. That is, you have to make sure that the resistances of the circuit that we are going to pass through, the input that you are going to pass through the circuit where you will be having some resistances. So those resistances should not change the input value. If the voltage drops correspond to the resistors is within the limits. If it retains the same value, say if logic 1 is inputted, output is also logic 1, then there is no problem. Otherwise, you have to properly study these resistances and we have to make the correct output has to be delivered. That is what the signal strength is. X square is not directly there in the Verilog. So shifting is there. Shifting is the X greater than symbols to greater than symbols. If you give 2, it will be shifted. But multiplication, actually, I have discussed a lot of the multiplies, different types of the multiplies. You can write a code for the multiply. But shifting can perform the using shifting. Shifter will be very a simple circuit when compared to the multiply. Shifter will be always, it will save the power, area, everything. So that is why normally we have multiplication with say some quantity x into A. If you express in terms of parts of the 2, then the multiplication can be easily performed with less circuitry, thereby area efficient, power efficient. So that is, there is a form called sum of power of 2's. You take any number, you can express as sum of powers of the 2's. Say for example 0.75. Okay. This can be expressed as 2 to the power of 1 by 2 means 2 to the power of -1 plus 2 to the power of -2. So this 2 to the power of -1 is shift, 2 to the power of -2 is also shift. If you want to multiply a variable x with 0.725, so that 0.725, the multiplier is not required. If you use 2 shifters, 0.5 plus 0.25. 0.5 is nothing but 1 by 2, which is 2 raised to the power of -1. A shift again 1 by 0.25 is 1 by 4, 2 raised to the power of -2, shift by 2 bits. Okay. So by just using 3 shift operations, you can perform the multiplication of 0.75 by x. If I want to design the multiplier, it will take a lot of circuitry. So Mealy and Moore model actually depends upon whether you are going to take the input directly to find out the output, or the output of the flip-flap to find out the output. So based on that, there is a difference between the Mealy and Moore models. So if you want to write the Verilog code for Mealy model also, this Mealy model actually is a state diagram. Okay. So after that, you have to follow the design procedure that I have explained in the lectures. Okay. So finally, you will get with the expressions for the input flip-flap input functions. Say if you have, two flip-flaps, JA, KA, JB, KB, and then finally output Y. So those expressions, Boolean expressions, you have to write the Verilog code for those flip-flap input functions and circuit output functions. For that, there is a design procedure is there that I have discussed in the regular lectures. So there may be some mistake in the code actually. If you want, you can send the code to my TS. You can put in the discussion forum. My TS will help. They will run the program and they will inform you where the mistake is there.
Is there any student? 2, 3, 4. Okay, you want to go to home. What is your name? Huh? Myself Atul. AI. Upload किया था?
My laptop is not charged.
Okay.
That's why I'm.
But you didn't have any class. I mean, you have 0 attendance till now.
Sorry?
You have 0 attendance.
Actually, sir, I'm not giving a but behind it there is a reason.
Whatever the reason, you will face the situation. I'm not taking the kind of responsibility.
Internship is going on.
Okay,
Actually,
so
why the modules are
I
not
don't
nested
know
in the
if
sense?
you have on that ground that you are actually not feeling well, right?
Yeah, actually, I have, because today you have said that by 9 I have to.
So nested in the sense actually, if you want to nest what happens is what is the corresponding digital circuitry. So we cannot design the digital circuitry for nested loops. So because here the code, every code you have to map onto the architecture. So for nested things, there is no architecture where we can implement the nested loops. So some questions will be from assignment and but this will be objective type only, all multiple choice questions only. So there will be some questions directly like assignment, and there are some few questions where I'll use some code, big code with 2 or 3 keywords missing. So you have to find out those keywords like that. Common data problems. So you'll be given some data and they will be asking about 3 questions based on that data only. So in that probably it will be some missing of some statements, or you'll be given a code and they will be asked to find out what is the output after running this program and yeah, loop is also similar to this C loops actually. Verilog is exactly similar to the C. In C, you can write the loops. In similar way, you can write the loops in the Verilog also. Yeah, one course actually just recording started on integrated circuits, basically the operational amplifiers and digital integrated circuits and A to D D2 converters. Mostly the operational amplifier course, just recording started. It will start from January 2024. There are some 2 TS, the Prime Minister, the PhD fellowship, 2 TS assigned, I think, but I don't know whether they have not reported me. So their duty is to take your live sessions and are programming everything. I'll just find out whether they joined or not. So for DC motor control using the FPGA, so basically how to give the digital signals. So if I give 0 to 5 volts, say DC motor operates with 0 to 5 volts. Okay, so you can give a voltage which is correspond to 0 volts so that it will be stopped. If I give 0.1 volt, it will run with a little speed. So between 0 to 5 volts, if I give the voltages, then the corresponding the DC motor will be runs. So for that, you can send the digital signal through the Verilog code, and you can use a to D convert, D to A converter, basically. So using the D to A converter, you can implement the DC motor emulators. Blocking and non-blocking is actually, as the name implies. Blocking means if I have A is equal to B, C is equal to D. So C is equal to D will be implemented after implementing A is equal to B only. That blocks it. Okay, that is called blocking assignments. Non-blocking means if I write 4 assignments, all the 4 will be executed parallelly. Okay? That is the difference. Blocking means one after the other only sequential type of thing. And the non-blocking is parallel processing. If you have many statements, all the statements will be executed parallelly. Whereas in non-blocking type, it is sequential. So you first perform the first operation. After that only you can perform the next operation. So like that, it will go in a sequential manner. Whereas in non-blocking, it's parallel manner. So the questions related to this assignment and all, you just send the mail, because these things my teaching assistants will look after. So I'll discuss with the teaching assistants. So Verilog, the practical session actually the 2 TS assigned actually, but they have not reported me whether they are continuing or not. I don't know actually. I just find out whether they are joined or they have just dropped the course. The session is not possible for that practical that to perform the coding and all. You can personally contact me and I'll request one of my TS who are present here, my research scholars. So they will explain you. Actually, you give integer also, basically it will be converted into ones and zeros only. But in text-based and all, the option is given that you can given the integer. But the digital computer, all the digital circuits understands only zeros and ones only. Even if you give that is actually for better understanding of the user, better access to the user. There is an option to give the integer values also, but the processing will be done in terms of zeros and ones only. Okay, I will inform my TAs. Who can join actually? This I have discussed in the lecture. Actually, exactly I don't remember now actually because I have recorded this just 2 years back. Just I have to refer back again. But it is there in my lecture. Otherwise, you cannot use these. It will give some syntax error. And regarding the segment, in which segment we can declare the initial value? Segment in the sense, what is segment? I don't understand. My mail ID is available in the IIT Guwahati website. You can go to IIT Guwahati website and EEE department. I'll just type here otherwise. Initial value will be normally its input and output port. How this initial value is nowhere related to the output port. Right? Initial value is normally will take the initial value in some register. Then after processing, the final output will be passed through the output port. That output port will be connected to the external device. The mail ID I have already given. Chat box here also I'll write. The frequency mainly depends upon the critical path of the system. Okay. So the computation time of the longest delay free path. Computation time of the longest delay free path is going to decide the frequency. So if you take the architecture, you see what is the path where the delay free is there, delay is not present, and what are the different computational blocks. Okay, if I know the computational time of each block, then that is going to decide the maximum frequency that you can apply. Yeah, Verilog use it in industry also. In the beginning of this live session only, I discussed that Verilog is better than VHDL because Verilog is like C-type language and it is easier to learn, as well as in industry also it will be very much useful. And Verilog is the latest language and VHDL is very old language. So obviously a new language means you will be having a lot of updates in that language. RTL schematic will be you can obtain the RTL schematic using Verilog also, but the which type of simulator that you are going to use, that depends. VLSI courses basically you have some digital IC design course. If you want to work in digital area, there is a digital IC design course. If you want to work in analog area, there is analog IC design course also. So basically here the VLSI is like this. So at the BTech level, UG level, normally you will study the analog circuits, either transistor based or MOSFET based. Similarly, digital circuits, combinational circuit and sequential circuits. Okay. So the advanced level is at the PG level normally. You have digital IC design and analog IC design. Means the entire IC. Okay. So that deals with the design of the IC and all. Okay. So that is the advanced level course. So you start with either you go in the analog domain or digital domain. First you complete this analog circuits course, which is a first level course where the transistor analysis, everything will be discussed. The next advanced course is analog IC design. directly you can design op-amp. All the stages of the op-amp, differential amplifier, level shifters, current, constant current source, and all. Finally, you can go up to the fabrication of that. Similarly, digital, you start with the just basic course on digital design. So start with combinational digital circuits, sequential digital circuits. Then you can implement this using this Verilog. This course is actually bridge between this the basic level and then the advanced level. Then you have a digital IC design where you will be completely using CMOS gates and how to form the layout of a circuit. Once if you know the layout, then you can go for the modeling of that particular semiconductor, modeling of that particular circuit. Then finally you can go for the IC design, IC fabrication. So like that can do these courses, basic level courses, analog circuit, digital circuits, analog IC design, digital IC design. Then you can go for the some sort of this testing, VLSI testing. There are some courses, advanced level courses, and VLSI layouts. Digital is basically the baseband processing and all. Front end and back end will be normally analog. So if you take the most of the real world signals, you take the real world signals in the sense in communication normally you will deal with audio signals and video signals. Audio signal is also analog signal, video signal is also analog signal. Okay, so the analog processing will be there up to converting this analog signal to digital. There are a lot of advantages of the digital signal processing. That is why people prefer the digital signal processing. But still, we have some analog signal processing. Like once if we measure the signal from the sensor, say a microphone, output will be electrical signal. That is very weak, that you cannot directly convert into digital signal. But before that, you have to do some amplification, some noise removal and all, low noise amplifier and all. So that part, that is called front end. That has to be designed by using the analog circuits only. Once and A to D converter we can call as a mixed circuit. A part of that one is analog, part is digital. Once if you convert into digital, after the A to D converter, all the processing will be digital. Again, if you want to get back this signal after processing, then the digital signal has to convert into analog. Again, due to a converter is also mixed design. So the output of that due to a converter is again analog signal. After that, if you want to do any processing, that is analog processing. So intermediate stages are all digital. After this A to D converter, before the A to D converter, all the blocks are digital. Before A to D converter, whatever the process that you have to do, that is analog processing. This course significance is basically actually nowadays in India actually. Recently, Government of India has announced several billion crores for establishing the IC technology fab, IC fab in India. So I think already they are planning in Mysore. They are going to start a plant where ICs will be manufactured. You might have seen it in the news also. So nowadays, actually, the main focus is on VLSI design where we can fabricate the ICs. So in order to fabricate the ICs, if you want to work in that domain, then Verilog course will be useful. As I have told, there will be two designs, two domains will be there, digital and analog. But in digital domain, wherever you want to design any digital circuit, Verilog programming is useful. Chandan's is a C-based course actually. So he's a computer science person. So I think he will not deal with the digital logic and all. But there is one course coming on digital domain only by another computer science faculty. That is, I think, digital design using Verilog. That is all similar type of the course. Here, because many faculty are there, there are a lot of similar type of the course. Already one course is already available. That is hardware design using Verilog or something is there. There are some similar type of the courses are there. You have an option, whichever you feel that it's understandable to you, it's useful to you, you can follow that. But in NPTEL MOOCs, there are many courses which are almost similar. this depends upon your personal interest actually. In analog also RFICs and all is a current research in this intense area. So this depends upon your personal interest. Even you can work on the mixed design also, like A to D DTA converters. Some companies prefer the digital people, some companies prefer analog people. Yeah, timing simulation cadence is possible. So 5 more minutes actually. 4 p.m. I have one more lecture at in another building. So if you have any questions, quickly ask in 5 minutes. So clock calendar is basically how to first design a seconds counter, then minutes counter. Every 60 seconds you have to update 1 minute. Then every 60 minutes you have to update an hour. Like that every 24 hours you have to update one date. So like that you start with the seconds, then minutes, update minutes, then update hours, then update the day and all. So like that you can implement the clock calendar. TFT is actually exactly I don't remember now actually. Coefficients basically you have to base it on the specifications. Verilog will not be used to find out the coefficients of a wavelet transform. You have to design You can obtain these coefficients using either the MATLAB or Python also. Once if you get the coefficients, then the designing part you can do it using Verilog. So in many of this type of image processing applications and all, where wavelet transforms will be used, you can use a part of program in MATLAB or Python. Then you can dump that program onto the Verilog. So work on FPGA, a lot of work is there. You are asking the FPGA related work at me or in general. Many students are working on both algorithms as well as their VLSI implementations. In that, they will be using FPGAs also. In general, you can take any algorithm and you can map onto the FPGA. You write the Verilog code correspond to that algorithm. You take any algorithm. You take machine learning. Nowadays, we have machine learning algorithms. You take an algorithm basically, and whatever the operations that are present in that algorithm, you can write the Verilog code. Then you first verify the functionality using a test bench. Once if it is verified, then you dump that program onto the FPGA. You give the physical inputs and you can check the physical outputs. Book is Samir Putnagar is the good book actually for Verilog, and nowadays a lot of material is available in social media also. A lot of books are available. So even if you follow any digital circuits book also, so in that also they are explaining the digital circuits. In addition to that, Verilog code also, like Maurice Pano and all, there are some books where both the theory as well as the Verilog implementation is also it's explained. So thank you for your participation. I have one lecture at 4 p.m. in other building. So thank you. Good luck for your final exam.